Hi guys, I wanted to go over this cell size assignment. It's 2.03, and if you take a look at the top, it's in the table of contents under cells, and I'm starting with the topic review because this is a really good example. So what it's saying is that you have a cell, let's say this is your cell. It helps to build these little guys because you can see this is cube size, but cells are three-dimensional, okay? But they have surface area, which is the flat, like the two-dimensional sides. That's the surface area, that's surface area. So area is length times width, okay? And the surface area is where the material or the food can be absorbed through. But it had, according to the volume, which is how big it gets, so this one's a littler volume, right? Because it's a tiny little guy. This one's bigger. So this one needs less food than this one, obviously, because it's smaller. So it has less requirements. But it still has it still has surface area, which is the flat side, length times width. So you have to figure it out. So the surface area, the flat sides, have a ratio to the size, like surface area per volume. The volume is the three-dimensional part. But this will tell you exactly how to do this. So for example, a cell can absorb a molecule of food for every millimeter squared on the surface area. So if you have this one and it's 2 times 2, so it's 4 millimeters squared, because 2 millimeters times 2 millimeters is 4 millimeters squared. So, but it can absorb a molecule of food for every millimeter squared per minute. So since this is 4, that would be 4 parts of food for that size. But in case of this, there's also 6 sides, so each side can absorb that much food. So here's the rate of absorption, 1 molecule per millimeter squared, but it requires 6 molecules per millimeter cubed to the third power. So that's the volume. So surface area and volume, how much will fit into that whole three-dimensional thing. Okay, let's just go through and go step by step. So this cube, they're saying, is 4 by 4 on each side. Each side of those squares are 4 millimeters. So the volume would be 3 sides. So it would be length times width times height. 4 times 4 times 4. And that equals 64 millimeters cubed, because you multiplied 3 numbers. 4 times 4 times 4. All right, so that's your volume. Now, we need to calculate how much food. So the cell needs 6 molecules of food for every millimeter cubed. So we already said that we've got 64 millimeters cubed, so we times that by 6, and we get 384 molecules of food. That's how much it needs. So then we have to get the surface area to see how much it can get. We know how much it needs. Now we have to see how much it can get. So it has, tells you the math. Area equals length times width. So 4 times 4 is 16 millimeters squared per side. Now we know there's 6 sides to a cube. There's 6 sides. You can count them on your cubes. So you take this 4 times 4, which is 16, and then you multiply it times each side. 6 times 16 is 96 millimeters squared. So it requires 384 molecules per minute. And the surface area the cell can absorb a molecule of food for every 1 millimeter squared of surface area. So we already figured out there's 96 millimeters, so it can millimeters squared. So it can absorb 96 molecules, but it needs 384. So that means this little guy's going to die because it can't absorb enough food. So the bigger the cell gets, the more surface area it needs, and it can't. So that's why cells stay very, very, very small, because it's just a limiting factor for that cell. It keeps it small because it can only get so much food. So the surface area to volume, even with a 3-to-1 ratio, this cell cannot absorb enough food. So when you analyze this, it says as a cell gets larger, the surface area to volume ratio gets smaller. That's what